Good morning to all. Myself Professor Archana from IIT ISM Dhanbad. We are in course of Introduction to Python and Petroleum Data Analytics. In the last class, we have started the linear regression. In today's discussion, we are going to focus on the regression matrices and then multiple linear regression. As we discussed in the last class, linear regression, where we do have three type of regression we do talk. One is the simple linear regression, and then next one multiple linear regression, and the lastly we do have the polynomial regression. So what is this regression, why it is important, and why we are going for this regression matrices? So regression fashion are algorithm used to expect continuous numerical values primarily based on the entering feature. So regression is the algorithm which is used to expect continuous numerical values primarily based on entering feature. In scikit-learn, we will use numerous regression algorithm which we have started with the linear regression, and in follow to that today we will be discussing the multiple linear regression, and then we do have a decision tree, random forest, support vector machine and others. So before entering to the regression matrices, so we have to know the true values and predicted values. So in the last class I do discuss there is a yi, that is our target, okay. Then we do have the yi hat, that is the value predicted, okay, from regression line or best fit line, okay. So we do have a target, and this target will have the actual value, then one value we do have the predicted value. So what we were discussing, there is a these two values are not matching, and that we do term as a error. So there is a error which we call yi minus yi hat. So this the error we do mention. So what is the error here? We do have yi target, then we do have a yi hat. So in the last class we have discussed this line, okay. So this the line, take this line, okay. So we do have this the one x-axis, okay, data on the x-axis and data on the y-axis. So this the one only we are talking about the simple linear regression, okay. So this the discussion where we do have this the best fit line or regression line. So in case of simple regression, we have one input and then one associated target or label, or we do mention output, okay. So when we do talk simple linear regression, we are only having one x value and one y value, okay, and there is a linear relationship between this x and y component. So x is the r on the x-axis and y, which is the target, it is on the y-axis, and between this x and y, what we are assuming in case of a linear regression, there is a linear relationship between the x and y. So x is your independent variable, okay, and what is y? It is a dependent variable, okay. So we have y is the function of a x, okay. So y is the, we can write this way, okay, fx is equal to y. So y is the function of x, we can write this way. Then we do talk about y, this when we will have the equation. So what it is, this line is nothing but the straight line. So what is the equation for the straight line? Y is equal to mx plus c. So m is your slope and c is nothing but the intercept, okay. So our discussion in the last class, which I focused on, are M determination and then the C determination. Okay. So this is the two value we determined. Okay. What is the objective here? We want the optimum M and C. For that, putting these two value M and C, my straight line, it should consider it is a best fit line. So what is the best fit line? So this the all this value which we do have, these are the observation point. Okay. So what we are seeing, there is a this, if we will see this particular value, so what is the y here, actual y, it does fall here, but according to this model, regression model, what would be the predicted value for this corresponding value? So this the one, it would be here. Okay, so this the one, it is the actual one. Okay, and this the one, we do have the predicted one. Okay, so this is the actual one and the predicted one. So what we see, though we draw a best fit line, there is some difference between our actual and predicted. Sometimes there may be the cases which all this difference line, we may draw one more. Okay, there may be the cases when all your line, so these are your observation. We do have, I was taking one example, that is your CGPA and your package. Okay, so package one in lakh per annum. Okay, so this is my CGPA, that is I am putting in the x-axis. So this is nothing but my input. Okay, then this is nothing but your output, or it is on the x-axis, or this is your nothing but the target. Okay, so this is your package. Okay. So there is a different scenario. In one scenario, you may be all your data point, it does fall on your regression line. So that means we do consider this is the best line. Why best line? Because the error which we do have, what error, how we define the error? So difference between the actual y minus yi hat. So yi hat is your value predicted from the model. So what is the model I am talking it here? Linear regression model. What the model we do have? We can call simple linear regression. So this is the model we are taking. So we do have some error is the nothing but the yi minus yi hat. So when this error is more, that means what? This line is having not accurately giving you the predicted value. So to measure all this accuracy, okay, we do have our regression matrices. Okay, so this is the one I am focusing today in our today's discussion. So when you do mention the regression matrices, we have some regression matrix. So one is the mean absolute error, and before that one more we do have. So in today's discussion, what we have seen previously, there is an error between the y actual and y predicted, and when this error will be less and less, my model is a more accurate. So that's the whole thing. So to check the accuracy or to check the error, what we do have? We do have some option available in the scikit-learn. So what are those options we have, which I am focusing it today? So first one is the mean absolute error. Okay, or we call it MAE. Then second one is the mean squared error or MSE. Then we do have the root mean square error. Okay, so that is a RMSE. Then the R squared error. Okay, and the lastly we do have a adjusted R square score. Okay, so 5 we do have. Okay, so we will move one by one. Okay, so this just I explain you why this error is important. Determining this error is important because we wanted to check what the model which we have, how accurate it is. So to check the accuracy, there should be less error. To measure the error, we do have some matrices which I am focusing it today. So let's start the first one. So first one, we do have a mean absolute error. So as the name suggests, we are just mentioning the absolute error. So how it should be. Okay, just take this one. This is the one we do have it here. The line which I am talking. Okay, so just take some line here. So these are my data point. Okay, you have this data point. Okay, so considering this the data point. Okay, assume there is a n data points, or you have the n observation. N observation we do have it. Okay, we have again the same example, CGPA and package. Okay, so this the CGPA versus package we are talking about, and this the one when we are taking only two column. So this the one we are just simplifying that with the simple linear regression. Okay, so that's the simplification we are doing it here. So this only two column. Okay, so one is the input and the another one is the target. Okay, that's the one. Okay, so let's see this one. So this is your y, so this is my x-axis. So what would be the error for this point? Okay, you just see this one, this is the actual one. So this is y I. Okay, and okay, when you draw the line, okay, so here also this is the prediction corresponding to this x value. Okay, both the places x is same, here also xi, here also you do have the xi. So this the one you do have the yi hat. So for the predicted, what we are mentioning, hat we are mentioning. Okay, so this the first data point I am mentioning. So in place of yi, I would be mentioning y1. Okay, and what is the actual y1, and what is the predicted one, y1 hat, and this is the actual. So what is your error? Okay, so error for the first point you have y1 minus y1 hat. Okay, so what is the error for the second point? Okay, second point, assume this is the second point we do have. Okay, so this the one actual is less but the predicted one more. So my this is my second point. So this is the first observation. Okay, this is my second observation. Okay, so y2 minus y2 hat. Okay, so this you are seeing, this is the one positive value, but this the one you do have a negative value. So to nullify the effect of a positive and negative, what we will be doing, just we will be taking the mode. Okay, so y1 minus y1 hat. Okay, then the second we are taking y2 minus y2 hat. Okay, now total error, what would be the total error you have? All point we require to consider y1 minus y1 hat plus y2 minus y2 hat. Okay, plus y3 minus y3 hat, like that it would be the n points. Okay, so total error, if you sum this all, I is equal to 1 to n yi. Okay, we can just remove this one. Okay, so this is the mod yi minus yi hat. Okay, so this is nothing but what it is. So this is the one, each one is the absolute error because we are not considering the sign. So this is actually the absolute error. Okay, so total error, now we have calculated. I have considered all the data points, so we do have the n data points. So this all summation, we each absolute error corresponding to each point we have to consider. Then the total error is the one summation I equal to 1 to n yi minus yi hat. So this is the total error, but what I am mentioning it here, mean absolute error. Okay, and here I is going, I is equal to 1 to n. Okay, so what you do have the mean absolute error, you require to take the mean. So mean absolute error will be, okay, just simply you do have a MAE equal to, already we do have I equal to 1 to n, and then mod yi minus yi hat by n. Okay, n is the number of observation. Okay, so that's the one. So this is nothing but the one we are looking for. This is the mean absolute error. Okay, so next we have come up with the equation for MAE. Now what we require to see, what are the advantages or disadvantages. Okay. So what the advantage here we can see, when you do calculate the mean absolute error, okay, your this value will be in the same unit as your target. So take the previous example here. This the y which we are mentioning, it is nothing but I am mentioning it as a package. So this is the lakh per annum. So your error is also in the lakh per annum. Okay, so just take this one. Okay. So now you do have this point. Okay. So if the value of the MAE, we get it something 2 point something, 2.3. Okay. So this will be the what it will tell us. Okay, what we have, yi minus yi hat by n. That's the one we are talking, MAE. So it gives us the interpretation. What is the mean difference between your actual in target? Okay. So this is also in the same unit, because what we are not taking any square in anything. Yi minus y hat only we are taking by n. So this is in the same unit as your target. So it is a more exponent. So this is the one benefit we do have. Okay. Now next. Second, you will have the outlier. Okay, so this the point we have here. Okay. Now this the point. Some point is here. Okay, some point is here. So what these 2 points? It are the outliers. So this technique or this method, MAE, okay, absolute mean absolute error, it is a not sensitive to outlier, or what we can do, it can handle outlier, or what we can mention, it is robust to the outliers. Okay, so this is about the mean absolute errors. Advantage we have seen it, it would be in the same unit, the value of MAE as your target. So this is going to be more understandable, the value. Okay, or for the interpretation. The second thing, with respect to your outlier, it is not sensitive, or it is a robust to the outlier. Now talking about the disadvantages. Okay, so in the last discussion we do talk about the simple linear regression. Okay, and then for that we do have a slope calculation, M and C calculation we made it. Okay. So there we have already seen previously, we have to come across your mean square error. So we already have some idea about the mean square error. So what is the error? Error, we have seen it. It is a difference between your actual and predicted. So any algorithm, it tries to minimize the error. If we apply any algorithm, objective is to minimize the error. Okay. So when the error will be less, you do have the more good model. Okay. So for that we are checking, we are having this all matrices. So second one we do have a MSC. Okay. So here the first one which we do talk, mean absolute error. Okay. So this the error, when we will have this one, it is not differentiable. It is not differentiable at 0. Okay, so when we have made the discussion last day for the calculation of M and C, what we had, we do have, we are varying the M keeping C constant. Then we do have the C constant, okay, and we are varying your here not M, okay, we can make it error, okay. So this is your error, and here this is your error and your slope, okay, with respect to error. So what we have seen it, we do have the like that structure. So we have to make the parabol kind of a thing. Okay. Not very good drawing, but it's okay. Okay. So this the point. What we have seen, it is a del E by del C or del E by del M is 0 here. Okay. So it is a slope with respect to C or with respect to M. Here it was a 0. Okay, so here it is a differentiable at this 0 point also. Okay, so at the minimum, here our error is minimum. Okay, here our error is minimum. So this is the one we are varying, keeping the slope constant. Here what we are doing, we are keeping the intercept constant. Okay, our whole objective when you do have a line, okay, so you do have a data point, different data point, to you want the best fit line. For the best fit line, you have the equation y is equal to mx plus c. Okay, so m or C is the only one which you can vary. So this the line is a function of what? M and C. Okay. So now y is the function of target is the function of your two parameter M and C. Okay. To solve this all, what we have done that we were varying the M, keeping the C constant, then varying the C, keeping the M constant. Okay. And then we come across this kind of graph. Okay. So seeing this graph, what we can see it here. Your error, it is a in when we do calculate the mean square error. Okay, MSE, when we do calculate the mean square error or mean, when we do calculate the MSE, what we are seeing, it is a differentiable at all the point. But in case of a MAE, it is not differentiable here. Okay, it is a 0 here. Okay. So the second we do have MSE. Okay, so this is the mean squared error. So what is the formula here for this one? What we have discussed in the last class? Okay, yi minus yi hat. Okay, and this square. Okay, and this the one we require to say summation of I equal to n. So this the one we do have here. Okay. Now we do have the second one. So we have seen this the uh, option with this one MSE. It is a differentiable at all the point. So what is this MSE? It is again it is a loss function. Okay. Okay. And how mathematically we will express this one MSE? We will be putting sigma of I is equal to 1 to n yi minus yi hat to the square by 2 by n. So n is the number of observation. Okay. So this is the one. So seeing the advantages, and we can see the disadvantages. So what the advantage here you do have? Okay. First, it is a why we are taking yi minus yi hat whole square, that the discussion you can refer the last video which we have discussed with respect to simple linear regression. So currently MSE we do have this one. When we do talk about the MSE, what first important thing, it is a differentiable at all the point. So it is considered as loss function. Okay. The second thing, talking about this your okay. So the second we do talk about this one with respect to your outlier. Okay, so one is the outlier, and then another one about your okay. So talking about the disadvantage, what the disadvantage here? If we see the value reported for MSc is the same thing, the example previously taken, CGPA and package. Okay, so what the package now it is giving? It is giving in a square. Okay, so whatever value we get it for MSc, it is a target square. It would be target square. So unit, if it is a lakh per annum, so what the value it will report? It is in square. Okay, so that's the one thing. Okay, interpretation we have to always consider before mentioning this. What is the loss? You require to take that into the consideration. KMSC is being reported in the square. Second disadvantage, it is a very much important with respect to the outlier. So it is a not good for the outlier. Okay, so it will be having the heavy penalized for the outlier. So that's the one thing. With respect to disadvantage, we do have one is the target. It will be reported in unit of a square, not in the same unit as a target. And the second, with respect to outlier, it is not good for the outlier. It is not able to handle the outlier properly. Now you can see this one. This is the one I have. Somewhere outlier I have, and this is my best fit line. This is my best fit line I am considering, and this the outlier I have very far or somewhere very far here. Okay, so when we are taking a square root of the difference between the actual and target. So it is a heavy penalized for the outlier. Okay, so this is the method. Okay, now the third one, RMSC. Okay, so simply what it would be, RMSC, how we are calculating root. So we have to take simply sigma I is equal to I1 to n. Okay, and then yi minus yi hat whole square by n. So this is your RMSC. One more we do have, two more still be left. One is the R score, and then second one the adjusted R score. So let's discuss that one. Now we have reached to the R2 score matrices. So what is this matrix? Okay. Now we reach to the R2 score matrices. So this R2 score, we can call it goodness of fit, or we can mention it is a coefficient of regression. Okay, so we can call the same thing R2 score. First the goodness of fit, and then we can mention coefficient of regression. We can call the R score with these two names also. Okay, so what is this R score here? What we have in the R score, you do have this the best fit line. So this is my regression line. Okay, this is my regression line, and here somewhere I do have a, this is the my mean line. Okay, so mean line. So in the R2 score, what we do calculate? We do calculate our regression line, how far from the mean line. Okay. So what the formula empirically, how we can represent this the R2 score? Okay, just let's see. R2 score we mention 1 minus SSR and SSE. So what is this SSE and SSR? SSE is the sum of squared error, okay, in regression. Okay, or SSR is the, sorry, this is, so what is SSR here? Sum of squared error in regression. Okay, and SSE, sum of squared error in mean. Okay, so the two things we can see it here. Okay, so go back to the next one. Okay, so seeing this one, okay, what we do have, this the one line, this is best fit line we do have, and this the one I am mentioning, this is my mean line. Okay, so this is the mean line. Okay, and this is my regression line. So here what we mention R2 is 1 minus SSR or 1 minus SSM. That's the two things I do mention it here. This we can mention SSM. Okay, that makes more sense. Okay, and this is also SSM. Okay, SSR and SSR. Okay. So this is the one. Okay. So elaborate more this one. Okay, 1 minus this we can write. Okay. SSR, what is the sum of a square error? Yi. Okay. Summation of I is 1 to n yi minus yi hat, okay, to the whole square, okay, and this is at the regression line. Okay, and this is the one I is equal to 1 to n yi minus yi hat whole square. This is at mean. You can mention mean. So this is the one we are calculating. So what would be the scenario? You will have this R2 value. It can be 0. Okay. So when it will be 0. Okay. So when these two will become 1. 1 it will become. When it will not become 1. When this will be 0. What could be the possible value of R2? R2 can be 0. R2 can be 1. R2 can be negative. Okay. So these are my possible scenario with the R2. So just discuss one by one. R2 is 0. So when it should be 0? When 1 minus 1 equal to 0. So when this side of numerator and denominator will become equal. So when these two are equal, we will have 1 minus 1 equal to 0. So when this scenario will occur? When these two lines, your mean line and regression line will fit to each other. This will overlap. So when these two overlap, the value will be the same. Okay. So that time your R2 will become 0. Okay. Then R2 is 1. Okay. R2 is 1. What does it mean? Okay. When you do have R2 is 1, when this the value is 0. This is the what? Regression line. So this is the one we are mentioning, regression 0 by anything, then that is 0. So this the whole thing will become 0. When this will become 0? When you do have a no error. Okay, so that is, it is the best one. Okay, regression line is the best line. It is not at all having the error. When this will become 0? When you have this, there is no difference between yi minus y hat. So these two are equal. When this will be equal? When your regression is predicting perfect value and it is matching with the actual one. When target is equal to the actual. Okay, or your predicted is equal to the actual one. So in that scenario, this the ever one will become 0. So that time your R2 will be 1. Sometime R2 will be negative. When you are not having the negative, when it will be, then your regression is performing very poor. So that time it will become negative. So that's the couple of scenario when we do have R2 score we are calculating. Okay. So that's the one thing about this the one. Okay. So this the different value of R2 we will have. Okay. So what in the R2 we are calculating? That's the thing. We are calculating our regression line is how far from the mean line. Okay. And then we do have the last one, that is the adjusted R2 score. Okay. So how we are going to calculate this one? Empirically, 1 minus, okay, 1 minus R2, okay, n minus 1, okay, by n minus 1 minus k. Okay. So let's see. R2 is the one, R2 is score, okay, and then n is your number of rows or observation, okay, and then k is nothing but the number of independent feature. Okay. So if we are having the two simple regression we are talking, when we do talk about the simple regression, that time what will happen? You only have the one target and then one input. Okay, so only 2, so independent value is 1, so k here becomes 1. Okay, when you do go for the 2 independent variable, okay, when you have the 3 columns, so 2 will be the independent variable, so accordingly it will change. Okay, so this is about the adjusted R2 square. Okay. Okay, the now next we do have a multiple linear regression using Python in machine learning. Okay, so we do get a good idea of the simple linear regression. Now we are moving to the multiple linear regression. Okay, so here what we are going to do in the multiple linear regression. Okay, so let's understand this one. Okay, now in the simple linear regression we do have only 2 columns. Okay, one is the input and another one is the output, or we call it target, or we call it label. Okay, so in multiple linear regression, as the name suggests, okay, it will have more than one input. Okay, so it will have more than one input. Okay, so previous example we have taken CGPA and package. We have done one simple linear regression module also on this data. Okay, in case of a multiple linear regression, now we are talking about more than one input. So let's add one more input, IQ, CGPA, then we may add gender. Okay, and then you do have a package. Okay, now what the data you have here, you do have the total 4 feature. Okay, and out of 4 feature, 3 feature is input feature and 1 is the output feature. Okay, so talking about this one, so this type of scenario when you do have more than one feature, okay, we do consider it is a multiple linear regression. Okay, so in case of a simple linear regression, okay, what we had equation y equal to mx plus c. Okay, that's the equation. Okay, so when we do take the line, what we are taking here in the 2 dimension, okay, when you have the x-axis and y-axis, you are taking the best fit line. Okay, okay, so you are taking the best fit line. Okay, and we do call it as a regression line. Okay, but when we do talk about the more than one column, so this line is not going to help us. What we are mentioning now, multiple dimension. Okay, and we do have dimension, multiple dimension we are talking about. Okay, so let's see, you do have the 2 feature. Okay, here IQ and CGP. Okay, and then you do have one target. Okay, that is my package. Okay, so when we do go, now we have to put the data in the 3D graph. Okay, so this is the one for the 3D graph what we have. Okay, so simply previously you have the line like that. Okay, so in here you are mentioning this is my regression line. When we do talk here, x-axis and y-axis. Okay, you do have the x-axis and y-axis. Now we are mentioning you have the 3 axis, IQ, CGPA and target. So now we require to have the 3D graph. So just to see this one. Okay, so this is the 3D graph x, y, and we can call that z. Okay, so here this line, the straight line is not going to help us. What we need a plane. Okay, so you just take this is the plane. Plane is required for analysis or for fitting. So here we are looking for the straight line which gives us the best fit line. In case of a 3D, we are going for the plane. If you have the 4D graph, okay, then we will have the hyperplane. Okay, here we are having the plane. Okay, okay. So for the 3D, what we are having the plane. So this the plane we required. When we do the next class, when we code for this one, multiple regression, multiple linear regression LR. Okay, and we are talking about, we are taking the 3 feature where two feature are input and one feature is output, we are going with the spline, which visually we will see in the coming class. Okay, so this the one we are clear till here. Okay, so the next what we have it here. Okay, in case of in case of a multiple linear regression. Okay, previous one for a simple linear regression LR. Okay, we have the equation like that, mx plus c. Okay, now we can take this the one in terms of beta. So yi we can mention, y we can mention. Okay, y we can mention beta 1 x plus beta 0. Okay, when you have only one x value. Now we are talking about x1, x2, x3. Okay, so what you should have? Now you should have for x1 we do have, okay, so beta 0, beta 1, x1. Okay, beta 2, x2. Okay, two line. When you have the three line, beta 3, x3. Okay, so like that, now you have this target is in terms of a beta. What we are mentioning, beta 0, here you do have the 3 points input feature. When we do have the multiple like n feature, when we are talking about, okay, like that we will be going to beta n xn. Okay, and how in summation term we can write it down, I equal to 1 to n, and then you do have the beta I xi. Okay, and that is nothing but your y. Okay, so this is the expression for the multiple LR, linear regression. Okay, so this we have reached it. What we can do, when you have beta is equal to only 1, x is only 1 point, it will reduce to this equation. Okay, it will reduce to the simple LR. Okay, so that's the thing for your empirical correlation for the multiple linear regression. In the today's discussion, we do discuss the mean absolute error. Okay, then we do discuss mean square error. Then we do had root mean square error, and the lastly two more we talk R2 score, or we do have the adjusted R2 score. So we do talk 5 regression matrices. Then lastly we get idea of the multiple linear regression. So this is all for today. See you in the next class. Thank you.